Right, so I want to continue reviewing a little bit today. Got some new stuff. If you don't get it out, if you got it already, which most people did, if you didn't get it, you need the order of operations handout. You're not gonna turn this in, this is just for your notes. We're gonna go through some of these sample problems in class though, so if you wanna write the notes like on this, that's fine. Use it as you will, I don't want it back. What we wanna look at today, we're gonna start to talk about some of the things a little bit that we do in algebra. Here's 3 verbs that apply to an algebra class. Some of these you're going to be pretty familiar with, and some of these maybe you're not as familiar with, these words. These 3. We'll add more to this list eventually, but these are 3 pretty important ones. A lot of times in math we'll ask you to do this kind of stuff, like on assignments for example, but I don't know if we always spend enough time talking about what they really mean. So let's just look, we're going to skip the top one. Solve we'll start to deal with next week. You probably have a pretty good idea what that means anyway. What about these bottom 2? Let's start with simplify. Give me like a 1 to 5 here. 5 meaning you think you understand what that means perfectly. 1 meaning I don't get that at all. I have no idea what simplify means. And I just want to kind of get a feel for where you are in here. Okay. All right, I've seen lots of fingers, which I would expect. Simplify is one that's pretty self-explanatory. What's it mean? Just very briefly, somebody help me out here. If you're going to simplify something, yes ma'am?
To make that expression as simple as possible.
Good. We're going to make the expression as simple as possible. Now this could involve variables, it could involve just numbers, right? For today the easiest thing to simplify typically is going to be an expression that has variables in it, which might sound strange. Variables usually you think of as being harder than numbers, right? But turns out, oftentimes, it's easier to simplify stuff with variables than it is with numbers. And you'll kind of see why here. We won't get all the way through this stuff today, but we'll get through most of it today, and we'll wrap it up on Tuesday. Let's take a look at an example now. This is the sheet that you should have. Right? If you don't have it, grab it here, please. Notice that, and you may not write anything on this, but sometimes these little handouts, there's going to be some little reminders on here that act as notes. That's kind of nice. We're going to look at some expressions, and there's a bunch of them on here that you could look at if you want to. I gave you online, there's a Moodle handout that fills in the answers to these, how you get all of these, how you do all these problems. You can look at that if you want to. Okay, it's already on the website. Above the assignment, it's one of those PDFs you can click on. You can print it out if you want to, or you can just look at it online. We'll only do probably 2 of these today, because they take a little while, and I want to talk through them and review some stuff while we go through them. But in each of these cases, and here's the first one we'll start with, that's a pretty complicated looking expression, isn't it? Right? There's lots of stuff going on there, lots of moving parts. We've got some exponents, we've got some subtraction, some absolute values, some multiplication and division. But one thing about it, there are no variables, right? So if I simplify this expression, now I don't want a specific answer, but what do you think my answer might end up looking like if I simplify that as far as I possibly can? 1 number. Yeah, exactly. If I've got a bunch of numbers jumbled together with a bunch of different operations, numbers combine together into just a single number, don't they? Right? So we should expect to come out of this with just 1 number, but getting there is the next step. Okay, so the next issue then is, there's a lot of stuff going on there. Math is very precise. This is, when we simplify this, there is 1 right answer, right? We've all got to get to that same right answer, but there's a lot of different paths that you theoretically could take. If you didn't know your algebra really well, and to be an Algebra 2, you're a pretty good math student. But if we were just to take somebody maybe who hadn't had as much math as you, and we said, do all this stuff, man, there's a lot of different paths they could take. They could do these operations in a bunch of different orders and get different answers every time. Now let's illustrate that with a simpler problem before we move on here. So what if we were going to do something pretty simple? What if we just wanted to simplify this expression? Say 10 minus 3 times 4. Okay, you all know probably how to do this, but how many operations are contained in that expression? 2. What's one of them? Multiplication. What's the other one? Subtraction. Okay, so really there's 2 paths that we could take here. We could subtract first. And if we do that, what are we gonna get? What's 10 minus 3? 7. So we get 7 times 4 is what? Okay. The other option would be to multiply first. So if we multiply first, what's 3 times 4? Okay, 1 minus 12, and what answer would that give us? I mean, they both seem reasonable if you don't think about it too much, right? We had two operations. In some ways, like if you didn't really know order of operations well, you might almost think the first option is better because you're just gonna do the left operation first and then do the right one. But we got different answers, so clearly we have to make a choice here, don't we? We've got to agree on a way to do this. Which one's correct? Bottom one, yeah. How do you know? PEMDAS, yeah, because of order of operations, right? So PEMDAS is what organizes the steps we take when we simplify expressions. And it's not arbitrary. It's not like it could have been some other way. It really turns out that PEMDAS is the way it has to be when you simplify numbers. There is one correct answer, and it's the one we get when we follow this particular sequence of steps, right? So how do we write PEMDAS? Let's see. What are the PEMDAS is spelled what? P E. Okay, now don't write it that way because that's wrong. You're right, those are the letters, but what did I do incorrectly when I wrote it down? Okay, good. I put multiplication above division, right? When we follow PEMDAS, it's sequential. We work from the top down, right? But the way this is written, it implies that parentheses come first and then exponents. That's correct. But then it says multiplication comes followed by division. That's not correct. Multiplication and division are on absolutely equal footing. We're just going to move from left to right across the expression, and whichever one we encounter first, we do. It might be multiplication or it might be division. It doesn't matter. They're equal footing. So we have to change the way we write this, and this is important. If you don't write it this way, you're likely to forget this, right? So you always want to write the M and the D next to each other, and the same thing's true for addition and subtraction, right? So we want to also put the A and the S in line so they're equal, right? Neither one comes before the other one. Okay, so let's let's follow this process here. But right away we come to an issue that's not a hard one, but it's something we got to make sure we understand. We always start with parentheses, right? That's going to be our first step. Do you see any actual parentheses up here? I mean, there really aren't any, technically speaking, there aren't any parentheses, but there's something that acts like it. What does the P really stand for? Grouping symbols, right? We say parentheses, but what it really means is grouping symbols, any kind of a grouping symbol, okay? So it's parentheses, but we remember that could be lots of different kinds of stuff, couldn't it? Right? Let's make a little list here. What are some things? What are some different ways we can group stuff in equations? Well, there's the obvious ones, right? We could have parentheses, or we could have brackets, or we could have script brackets. Those are all pretty obvious. But what are some other ones that are maybe less obvious? Absolute values. Yeah, we could have absolute values, right? So the absolute value of like 3 minus 7 or something, right? We got to work inside those grouping symbols. Sometimes they're not even that obvious. Like can anybody think of some other places where we group things, where, even though it doesn't look like a symbol, it still counts as a grouping symbol because things are being grouped in the expression? Yeah, square root. How about that? What if we did something like we had the square root of 9 plus 7, right? We'd have to rewrite that as the square root of 16. Anything that's inside of any function doesn't even have to just be a square root function. It could be a trig function like a sine or a cosine or a tangent function or something. You haven't worked a lot with those, but you will. Could be some other kind of function. Anytime we've got stuff happening inside of a function, that's implied that it's grouped together. We want to simplify that first, right? So there's a good example. What's another one you see quite a bit? Say it again?
Squaring something,
I mean, it could be. It could be we do something like 2 plus 3 squared, right? So we have to add the 2 and the 3. It's another one. Fractions, yeah, how about that? What if we did something like this? What if we had something like 12 plus 24 over 2 plus 4, for example? There are no parentheses written there any place, but they're implied. Anytime you have multiple things going on in the top or the bottom of a fraction, there are implied parentheses around the entire numerator and the entire denominator. So we always want to deal with, we have to do something like this. Even though, I mean, you can write it if you want to, but even if you don't, that's implied, right? That make sense? So that P, there's a lot more to that P than just meets the eye. Anytime things are being grouped, that's the first level in order of operations, okay? All right, so what's being grouped up here? Okay, I got an absolute value, don't I? Right, so we have to deal with that first. So step number 1, and the way I'm going to do this in the notes, just so this makes sense here, we're going to work through these steps, and as we move down through the order of operations steps, we'll just create a new row every time, right? The part that's not written in black is the part that's we're actually doing something to. You'll see what I mean. Like, so for step number 1, this is the part that we're working with. It's just right here. Square root of -8. We got to simplify that. Everything else would just stay the same. What is the square root of -8?
It's 8.
It's 8. Okay, good. Times 6 divided by 16. Okay? Good. There's step 1. How about step 2? Exponents. Do you see any exponents?
4.
Sure. 4 cubed, right? There's an exponent. Good. So next step, step 2. What is 4 cubed? What was it? No? I heard it. 64. 64, good. And then minus 8 times 6 divided by 16, right? Okay, so there's our exponent step. Now we'll move on down. How about step 3, multiplication and division? Well, a couple. We got 8 times 6 and 6 divided by 16. Which one has to come first? 8 times 6. We're going to go from left to right. Good. So step 3. Really, there's 2 parts to step 3, to the multiplication step. We get 64 minus, what is 8 times 6? 48. There you go. 48 divided by 16. And then we can go one step further. 64 minus, what is 48 divided by 16? 3. Okay? And then finally, we get down to step 4, which is addition and subtraction. And there's only one thing to do. 64 minus 3 is what? 61. Good. Okay, good. Now, you might be thinking, and you'd be correct, could we have taken some reasonable shortcuts there? Did I have to write down that many separate steps? I can't. But does anybody see a way I could have maybe shortened this up just a little bit? What do you think?
We could have done step 1 and 2 at the same time.
Okay, we could have done step 1 and 2 at the same time. Here's why. Even though step 1 comes before step 2 in the order of operations, I've got to do parentheses before exponents. Notice that we already know that addition and subtraction are guaranteed to come last, right? Any addition or subtraction that's happening outside of grouping symbols has to be the last step. See where I'm going with this? So we know right away that because this is a minus sign that's not inside any grouping symbols, that's got to be there until the very last step, doesn't it? Everybody see that? So if we want to, then, being as we know that we're not gonna combine these two terms into a single answer until the very last step, why not work individually on each part, on the term to the left of the minus sign and the term to the right of the minus sign? It's not gonna cause any problems because we don't get to that step until the very end anyway, right? So we could have turned this into an 8, and at the same time, we could have made 4 cubed into a 64. Would have saved a little bit of time there, right? Everybody agree? Okay? If you're not sure, that's fine, keep them separate. But as you get a little practice with this, I think that'll make sense. All right, let's move on. How about one more of those? This guy. Now this is kind of an uglier one. There's a lot more stuff going on here. And I would argue that if you can do this one, you can do any of the ones on the assignment. This is about as hard as it would get. Okay? Lots of stuff there, right? We've got, look at the top of that. Now, we know we've got a fraction, agreed? So everything in the top, consider that to all be grouped, and everything in the bottom is all grouped. And here's our strategy. When we're simplifying an expression that involves a big, ugly fraction like that, we're just going to finish the top of the fraction completely, finish the bottom of the fraction completely, and then at the very end, we'll simplify that fraction, divide it out, right? Okay, but what about the top of this? In the top of the fraction, I've got some brackets enclosing some parentheses, enclosing some absolute value bars. So when we write down PEMDAS, and I would encourage you to always do that for now, so you kind of organize your thinking about this. Which set of parentheses, or which set of grouping symbols has to come first on the top? You're right, how come? It's the innermost. Good. When we've got a bunch of grouping symbols that are inside of each other, you always want to start with the one on the inside first and work your way out, right? So the first thing we would do for step 1 here is we're going to deal with this stuff right there. The absolute value of -6 plus 2. Well, maybe we can combine some steps here. What is -6 plus 2? -4. So really we're just taking the absolute value of -4. And what is that? 4. Okay? Good. So step 1. On the top, we've got inside the brackets 15 minus the quantity. We can turn all that stuff into a 4, right? Anything else we can do on the top? Why not? Right? We've got a square root of 9 that's being added to this stuff. Right? We've got that plus sign. So why not simplify that square root of 9 into a what? 3. Okay, good. Kill 2 birds with 1 stone there. Well, why not also, the bottom is separate from the top, isn't it? Why not simplify the bottom while we're at it? So on the bottom, what's the first thing we could do? Exponents, good. So inside the bottom, inside that set of grouping symbols, exponents would come first. So on the bottom, we've got a 3 minus, what is 3 cubed? 27. Good. Okay, so we got accomplished a lot there with step 1. Okay, step 2. Okay, now what? On the top, what comes next? 4 plus 3. So on the top, we've got the quantity 15 minus, what is 4 plus 3? And on the bottom, we're done, right? What's the bottom going to look like? 3 minus 27 is? 4, I heard it. Good. Okay. So then on the top, 15 minus 7 is? On the bottom, we've got our -24. Another question for you. Do I need those brackets on the top? You're right. How come? Say it again. Nothing to simplify, right? think what grouping symbols mean. When you group stuff, it really only makes sense to group more than one thing at a time, right? Grouping implies you're taking multiple things and putting them together. So grouping one thing is kind of like the sound of clapping with one hand. Doesn't make any sense, right? So you can leave it there. It's not hurting anything, but we could certainly get rid of that also. Anytime you get down to a single thing that's in a quantity, you can get rid of it, okay? Well, we're about done. So we end up with what on the top end? What is 8 squared? Over. Okay, well, we're getting there. We're pretty close. Now we've got this down to a single fraction. One other little issue with this, that's kind of dorky to have a positive number divided by a negative number. You'd never put the negative number on the bottom. Where could you put that negative that goes with this fraction? You could put it on the top, negative 64 over 24. That would be okay. That's fine. I have a preference, personally, I like to put it out front. Because really, we've got this fraction, and the rule is positive divided by negative makes the sign of the fraction negative. So I would prefer, personally, to write that as negative 64 over 24, negative 64 24ths, okay? But we're still not quite done because that can be reduced. So let's review how we do that a little bit. Okay, so it's been a while since you've done this stuff. You know how to do it. Help me out here. Describe, what are some approaches we could take to...
You can take 8 out of 12.
Okay, what do you mean by that?
Divide 8 into 64.
Okay, good. We want to find a number that divides into both 64 and 24. 8's a great choice because that's the biggest number that divides into both. Is it wrong to divide by something smaller than that? Like, let's say that we saw that 4 went into both of those and we divided them both by 4. Then we just got to keep going with it, right? But it makes it easier. Every time we do it, it makes it smaller and easier to deal with. It's nice if we can get it in one step if possible. So here's the way I'm going to write that. 8's the number that divides into both of those, right? So we're going to factor the top one into not 64. 64 is 8 times what? 8. On the bottom, we get 24 is 8 times 3. And then if we have common factors on the top and the bottom, we can cancel those, right? So we end up with our answer being negative 8/3. Okay, make sense? Good. All right. Okay, that's good. A lot of stuff going on there, right? So next issue. The next group of problems on that little handout you've got there, it asks you to evaluate the expression. Okay, so if we're doing that, if we're evaluating these expressions, there's a word I bet not as many people feel as comfortable. Now, give me a 1 to 5 on this one. How many people feel like you know exactly what we mean when we say evaluate something? So 5 would mean I completely understand that. 1 would mean I don't get it at all. Somewhere in between would be, okay, yeah, as I expected. I'm not seeing so many fingers up this time, right? That may be a word that we're not as familiar with, but it's an easy one to remember. It contains the word value. Value can be complicated outside of math. If I want to ascribe a value to a person, oh my gosh, it's impossible to do. I mean, there's so much that goes into a person. Even if I want to give a car a value, I mean, that's hard to do, right? Different people might say different things. But what's the value of the number 11? 11. That's it. Numbers are easy, right? The value of a number is what the number is, right? How much it represents. So evaluating expressions in math is dead simple. All you're going to do is you're going to enumerate. You're going to plug numbers in for an expression and see what you get when you simplify. So what do you think it means then if I'm asked to, we'll take this one, number 10 for our first example. What do you think it means, if we're asked to evaluate the expression 3r minus 4s when r equals 5 and s equals 2/3. What are we doing? Plugging them in. We're plugging in the values and simplifying. That's it. That's simple, okay? So we end up then with, this is equal to 3 times, now what I like to do with this, and this I think is a really good strategy, every place if we have a variable that we're plugging in a value for, the first thing you do is you just open a set of parentheses where that variable used to be, because you're going to plug in a number there, right? So let's write the template before we even plug anything in. So I'm going to get 3 times r, right, the value of r, minus 4 times the value of s. Well, the value of r that we're plugging in is 5. The value of s that we're plugging in is 2/3. So our answer is 3 times 5 minus 4 times 2/3. We just need to simplify that into a single number, like we did in the last examples, right? So the first part is pretty simple. 3 times 5 is what? 15, no problem. The second part, a little tougher. We got to remember how we multiply by fractions. So 4 times 2/3. Any suggestions how we might do that? What do you think? You multiply the denominator. Now, hold on now. Let's. You're on the right track, but let's make an adjustment here. Anybody else want to add something to that?
I don't know if I'm right. Maybe like 4 over 1.
Great idea. Okay. If we're multiplying something by a fraction, it's easier to think of if you're multiplying fraction by fraction. Then we don't run into the problem of where does the 4 go, top or bottom, right? So we'll write the 4 as a 4 over 1. Now, what is our rule for multiplying fractions? It's actually easier than adding or subtracting. No. You're thinking about maybe like if you're solving a proportion or something. Multiplying fractions is even easier than that. You multiply. No, you guys are making this way too hard. Straight across. That's it. Multiplying fractions is the easiest thing you can do with fractions. You just multiply straight across. So this is going to give us 4 times 2 is 8, divided by 1 times 3 is 8. Make sense? Okay? We're getting there. Now I've got 15 minus 8/3. Okay, last step here really. Right now we've got to subtract a fraction from something. But what's our good strategy if we're adding or subtracting with some fractions? What should we probably do to everything? Make it look like a fraction. So 15 as a fraction is what? 15 over 1. Good. So now we've got 15 over 1 minus 8 over 3. Unfortunately, adding and subtracting fractions, as you might remember, is a little tougher, right? What do we always have to have before we can add or subtract fractions? Common denominator, right? We have to have a common denominator. So now the search for a common denominator. This is where I think it's been a long time since you've done math, so let's make sure we get this back in our heads correct, okay? The common denominator is always going to be the least common multiple of the denominators, okay? Let me write that down. Common denominator equals the least common multiple of all denominators. Least common multiple, that's a big word in math. That's sometimes we just write it as LCM, right? You probably remember that. Let's break those words down. What does least mean? Smallest. So we want the smallest. Common means, like when you go to college, usually in your dorm, you're going to have individual rooms, and then there's going to be a common area. What's that mean? Say it again.
For everyone?
Everyone can go. So it's a shared place, right? Everybody in the dorm shares that place. So common means shared. And multiple, what are the multiples of a number? Let's make a list. What are the multiples of 3? 3 times 1 is 3. 6. 3 times 2 is 6. 3 times 3 is 9, etc. Right? What are the multiples of 1? So 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, and so on. Well, what's the first one that we see that's shared? 3. Right? So another way to think about that is a least common denominator is going to be the smallest number that both 1 and 3 could divide into evenly. Well, in this case, that's 3, isn't it? 3 divides into 3 one time, and 1 divides into 3 3 times. Make sense? Okay, let's just get a little practice with that real quick. One more example. I know this is kind of old hat stuff, but like I said, it's been a couple months with doing no math. You probably haven't thought about this stuff. What if we had something like, let's say, 2, not 2. What if we had 5, 6 plus 3/8? So our denominators are 6 and 8. What would be the least common denominator? 24. Yeah. Right? And we could see that if we made a list out of the multiples of 6 would be 6, 12, 18, 24, 30. The multiples of 8 would be 8, 16, 24, 32. And once again, we'd see that 24 is the first common one we get to, right? Okay? So then, back to our problem here. If we know that the least common denominator is 3, now the next issue is, how do I get a 3 in the bottom of each fraction? I'm hearing a couple things, and they're on the right track here. Go ahead.
You multiply the denominator and the top, so it fits in, so.
Okay, good. I'm going to multiply both the top and the bottom by 3, right? Now, think about why that is. If I were to put this into a calculator, I want you just to imagine this for a second. If I were to put this into a calculator, I would get 15 minus 8/3, right? 8 divided by 3, and I'd push a button and get an answer, right? Whatever I end up replacing the 15 with, if I were to push it into a calculator, it would still have to give me back the same value, which is 15, because my answer will change if I change the value of that fraction. So if I multiply both the top and the bottom by 3, I'm going to get 45 over 3, right? Well, if I put 45 divided by 3 in a calculator, what's it going to give me back? 15. So I did it right. I didn't change the value, I just changed the way the fraction looked. Everybody agree? Okay? There's another way of thinking about this, and this is one of those times you gotta really focus your thinking on this, because this is a kind of a breakthrough moment, just a little bit. A little light bulb's going to come on here. What is 3 divided by 3? 1. So we just multiplied 15 by 1, didn't we? If we multiply by 1, that's just an example of the identity property of multiplication. 1 times anything doesn't change it, does it? Right? So we just applied that in a tricky way. We multiplied 15 by 1, so we kept the value the same, but the 1 is in the form 3 over 3, so it changed the denominator to what we needed it to be. That's pretty tricky, right? I know you've done that 1,000 times in your life, but maybe you've never really thought about what is it really doing, right? It really is just changing the look, but not the value, okay? So we end up getting, this first fraction is going to become, if I multiply straight across, you already told me, 45/3 minus 8/3. And now because I have common denominators, I can do this easily, right? What is 45/3 minus 8/3? What is it? 37/3, right? So we end up with, I'm going to write this again. 45/3 minus 8/3 equals 37/3. One thing you could even do here if you want to is you know you've already got a common denominator, so put a big fraction bar there, and we know that we're going to get a 3 on the bottom. What do we get on top? Well, whatever we get when we subtract 45 minus 8, right? So the answer is 37/3. Make sense? Okay? All right, last step, and then I don't think I'll even do this today. I think we'll I'm gonna skip that for now. We'll come back to those next week. I just wanna show you, here's the last section in the homework. I wanna show you that even though it's the last one, and we're simplifying expressions with variables, I want you to see that it's easier. It's actually easier than what we just did. So let's pick like the hardest one up here, like this number 20. And let's look at that one. So I've got -8 times 2x, the quantity 2x plus y, minus 3 times the quantity -5x minus 2y. Now this time when I simplify that, it has variables in it, so I should not expect to get back a single number, right? We're not evaluating this time. We're trying to just simplify this, like we did in our first couple of examples where we had only numbers, but there was a lot of work to do. What can I do here? To simplify, I'm just going to distribute first of all, right? And if I want to follow order of operations, let's just write that down again. I want to show you that this still works with order of operations. Inside the parentheses, I have some parentheses here, but there's nothing to do. 2x plus y, I can't simplify that. They don't combine. How come? I've got x's and y's. Those are not like terms, are they? I can't combine those, right? That'd be like saying 2 oranges plus 1 apple is what? Well, 2 oranges and an apple. They're different things. I can't combine those into 3 of something because they're different. Same thing here, right? So the parentheses step, we can just skip completely. There are no exponents. The very first thing we see is multiplication. I've got -8 times this whole thing, which means I'm going to distribute, right? And the same thing with the -3. So what do I get when I do that? What's -8 times 2x? Okay, good. I get a -16x. -8 times positive y. -3 times -5x. Good, positive 15x, and -3 times -2y. And now look, now all I gotta do is just go down to the last step, which is add and subtract, which means I'm just gonna combine like terms. That's all I can do. So what about the x's? -16x plus 15x is what? -x. -1x, we're gonna write the 1 too, just -x. And -8y plus 6y. And that's our answer. Good? Okay, you got it. So there's an assignment up. Are we out of time? We're out of here like in 2 minutes. Yeah, don't worry about it. So you got an assignment you can be working on a little bit. Obviously, I'm not going to make that due till, let's say, next Wednesday. You can come back and ask questions if you need to after the long weekend. Okay? But you get a jump on it at least a little bit. Okay.